Everyone, welcome to Dr. Ravi's Academy. In today's class, you will be learning Davis steering mechanism and its derivation. Let us see the constructional details of the Davis steering gear mechanism. You have two bell crank levers. It is CPA is one bell crank lever, DQB is another bell crank lever, and PQ is front axle. As you know that in Davis steering gear mechanism, the total mechanism is mounted in the front of the front axle. So this is what exactly the constructional details, and you have sliding pairs. It is a piston cylinder arrangement. You have both sides, and this distance remains constant. It cannot vary. So you have a bearing. So the distance between the cross arm, AB is called cross arm, and front axle is a fixed distance, that is H. Now let us proceed to derive the expression for the angle alpha in Davis steering gear mechanism. So let us look at this. Let us consider you are negotiating a left turn. The moment you negotiate a left turn, here this cross link is slided to the left by x displacement. In mean configuration it is d, and this becomes d minus x. So in left triangle the opposite side is d minus x, and adjacent side is which is fixed, it is h. The other side you see that it is in mean distance is d, and as it is deflected to the left, you will be having d plus x is the opposite side of this right angle triangle, and angle becomes alpha plus phi, and that is outer turning angle, and here alpha minus theta is inner turning angle. So this distance, the adjacent side remains constant because the cross arm is most slides parallel to the your front axle PQ. Now let us proceed to derive from these two right angle triangles. Let us consider these two right angle triangles, and first you write the expression for tan alpha minus theta. So it is tan alpha minus theta is opposite side, that is d minus x divided by your adjacent is h, and expand this, you have tan alpha minus tan theta divided by 1 plus tan alpha and tan theta is equals to d minus x by h. If you cross multiply and substitute tan alpha value in mean configuration, that is d opposite side by adjacent side. So you have h multiplied by, here it is tan alpha is d by h minus tan theta is equals to d minus x into, you have 1 plus tan alpha is again d by h into tan theta. So now you expand it, you have here it is, you have d minus h tan theta left hand side is equals to right hand side, you have d minus x first term, and plus it is d minus x into d by h times tan theta. Let us bring the term tan theta term to the right hand side, and you bring this d minus x to the left hand side. So what you have is d minus d plus x is equals to, if you take common tan theta, you have here h plus d minus x into d by h. So d gets cancelled and x is equals to, you have tan theta, and if you simplify, you are going to get h square plus d square minus xd divided by h, and you can write down the expression for the tan theta is equals to, it is xh divided by, it is tan theta is equals to xh divided by h square plus d square minus xd. So this is left side right angle triangle. From right side triangle, right angle triangle, you can write down the expression for tan alpha plus phi is equals to opposite side d plus x divided by adjacent is h. If we expand this and simplify, you are going to get tan phi is equals to x h divided by h square plus d square plus xd. So this you can, in the similar way you can simplify. After calculating these two values, you can substitute into the condition for the correct steering gear mechanism, that is cot phi minus cot theta is equals to W by L. So here cot phi is, you can write down reciprocal of this, that is h square plus d square plus xd divided by xh minus cot theta is h square plus d square minus xd divided by xh is equals to W by L. So here h square d square gets cancelled, and the leftover terms xd plus xd, that becomes 2xd divided by xh is equals to W by L. So you can further simplify here. D by h is nothing but your tan alpha. 2 tan alpha is equals to W by L, and finally your required expression is tan alpha is equals to, it is a W by 2L. So this is what is the required derivation for the alpha. Thank you.